What's up, everybody? How y'all doing? Desktop audio, microphone. Broadcast mic. There we go. Alright, so I can turn that up. Desktop audio turns down. Perfect. Why is there only like one freaking thing for OBS? That's really weird. Oh, that's why. Oh, wait. Is this okay? This is source visibility. Okay. Get cam. Okay. Cool. Okay, cool. Okay. All right, so we got everything set up here, I think. Resume. Course feedback, discussion.
What is IAM? IAM is a web service that enables you to manage access to your AWS account and resources. It also provides a centralized view of who and what are allowed inside your AWS account, authentication, and who and what have permissions to use and work with your AWS resources, authorization. With IAM, you can share access to an AWS account and resources without having to share your set of access keys or password. You can also provide granular access to those working in your account, so that people and services only have permissions to the resources they need. For example, to provide a user of your AWS account with read-only access to a particular AWS service, you can granularly select which actions and which resources in that service they can access. Get to know the IAM features. To help control access and manage identities within your AWS account, IAM offers many features to ensure security. IAM is global and not specific to any one region. This means you can see and use your IAM configurations from any region in the AWS Management Console. IAM is integrated with many AWS services by default. You can establish password policies in IAM to specify complexity requirements and mandatory rotation periods for users. IAM supports MFA. IAM supports Identity Federation, which allows users who already have passwords elsewhere, for example, in your corporate network or with an internet identity provider, to get temporary access to your AWS account. Any AWS customer can use IAM. The service is offered at no additional charge. What is an IAM user? An IAM user represents a person or service that interacts with AWS. You define the user within your AWS account, and any activity done by that user is billed to your account. Once you create a user, that user can sign in to gain access to the AWS resources inside your account. You can also add more users to your account as needed. For example, for your cat photo application, you could create individual users in your AWS account that correspond to the people who are working on your application. Each person should have their own login credentials. Providing users with their own login credentials prevents sharing of credentials. IAM user credentials. An IAM user consists of a name and a set of credentials. When creating a user, you can choose to provide the user access to the AWS Management Console, programmatic access to the AWS Command Line Interface, AWS CLI, and AWS Application Programming Interface, AWS API. To access the AWS Management Console, provide the users with a username and password. For programmatic access, AWS generates a set of access keys that can be used with the AWS CLI and AWS API. IAM user credentials are considered permanent, in that they stay with the user until there's a forced rotation by admins. When you create an IAM user, you have the option to grant permissions directly at the user level. This can seem like a good idea if you have only one or a few users. However, as the number of users helping you build your solutions on AWS increases, it becomes more complicated to keep up with permissions. For example, if you have 3,000 users in your AWS account, administering access becomes challenging, and it's impossible to get a top-level view of who can perform what actions on which resources. Only there were a way to group IAM users and attach permissions at the group level instead.
There is.
Guess what? There is. What is an IAM group? An IAM group is a collection of users. All users in the group inherit the permissions assigned to the group. This makes it easy to give permissions to multiple users at once. It's a more convenient and scalable way of managing permissions for users in your AWS account. This is why using IAM groups is a best practice. You have an application that you're trying to build and have multiple users in one account working on the application. You might decide to organize these users by job function. You might want IAM groups organized by developers, security, and admins. You would then place all of your IAM users in the respective group for their job function. This provides a better view to see who has what permissions within your organization and an easier way to scale as new people join, leave, and change roles in your organization. Consider the following examples. A new developer joins your AWS account to help with your application. You simply create a new user and add them to the developer group, without having to think about which permissions they need. A developer changes jobs and becomes a security engineer. Instead of editing the user's permissions directly, you can instead remove them from the old group and add them to the new group that already has the correct level of access. Keep in mind the following features of groups. Groups can have many users. Users can belong to many groups. Groups cannot belong to groups. The root user can perform all actions on all resources inside an AWS account by default. This is in contrast to creating new IAM users, new groups, or new roles. New
Roles,
IAM
so it's okay
identities
with the
can
role.
perform no actions inside your AWS account by default until you explicitly grant them permission. The way you grant permissions in IAM is by using IAM policies. What is an IAM policy? To manage access and provide permissions to AWS services and resources, you create IAM policies and attach them to IAM users, groups, and roles.
So what's a role though?
Whenever a user or role makes a request, AWS evaluates the policies associated with them. For example, if you have a developer inside the developers group who makes a request to an AWS service, AWS evaluates any policies attached to the developers group and any policies attached to the developer user to determine if the request should be allowed or denied. IAM policy examples. Most policies are stored in AWS as JSON documents with several policy elements. Take a look at the following example of what providing admin access through an IAM identity-based policy looks like. Version, October 17, 2012. Statement, effect, allow. Action, asterisk. Resource, asterisk. In this policy, there are 4 major JSON elements: version, effect, action, and resource. The version element defines the version of the policy language. It specifies the language syntax rules that are needed by AWS to process a policy. To use all the available policy features, include version, October 17, 2012 before the statement element in all your policies. The effect element specifies whether the statement will allow or deny access. In this policy, the effect is allow, which means you're providing access to a particular resource. The action element describes the type of action that should be allowed or denied. In the above policy, the action is asterisk.
Oh, never mind.
This
Which
is
is
called a
wild.
wildcard, and it is used to symbolize every action inside your AWS account. The resource element specifies the object or objects that the policy statement covers. In the policy example above, the resource is also the wildcard asterisk. This represents all resources inside your AWS console. Putting all this information together, you have a policy that allows you to perform all actions on all resources inside your AWS account. This is what we refer to as an administrator policy. Let's look at another example of a more granular IAM policy. Version, October 17, 2012. Statement. Effect, allow. Action. IAM, change password. IAM, get user. Resource. ARN AWS IAM 1234567891012 user/$ AWS username. After looking at the JSON, you can see that this policy allows the IAM user to change their own IAM password, IAM, change password, and get information about their own user, IAM, get user. It only permits them to access their own credentials because the resource restricts access with the variable substitution $AWS username. Understand policy structure. When creating a policy, it is required to have each of the following elements inside a policy statement. Element. Description. Required. Example. Effect. Specifies whether the statement results in an allow or an explicit deny. Heavy check mark. Effect, deny. Action. Describes the specific actions that will be allowed or denied. Heavy check mark. Action, IAM, create user. Resource. Specifies the object or objects that the statement covers. Heavy check mark. Resource are an AWS IAM account ID without hyphens user/Bob. External site, what is IAM?
All right, so you've learned about IAM users, groups, and policies. Policies can be applied to AWS identities, like users and groups to assign permissions. They also, however, can be applied to another AWS identity, IAM roles.
Okay.
An IAM role is an identity that can be assumed by someone or something who needs temporary access to AWS credentials. Let's dive into what I mean when I say AWS credentials. Most AWS API calls that are made must be signed and authenticated, but how does that process work? When you send HTTP requests to AWS, you must sign the request. This signing process happens programmatically and allows AWS to verify your identity when a request is made and run through various security processes to ensure a request is legit. IAM users have associated credentials like an access key ID and secret access key that are used to sign requests. However, with regards to our architecture, the code running on the EC2 instance needs to sign the request sent to S3. I already told you that I don't intend for you to create an IAM user with credentials to be used by this app. So how will the application gain access to the needed AWS access key ID and AWS secret access key to sign the API call? The answer is IAM roles. IAM roles are identities in AWS that, like an IAM user, also have associated AWS credentials used to sign requests. However, IAM users have usernames and passwords as well as static credentials, whereas IAM roles do not have any login credentials like a username and password, and the credentials used to sign requests are programmatically acquired, temporary in nature, and automatically rotated. In our example, the EC2 instance will be assigned an IAM role. This role can then be assumed by the application running on the virtual machine to gain access to its temporary credentials to sign the AWS API calls being made. A role can be assumed by many different identities, and they have many use cases. The important thing to know about roles is that the credentials they provide expire, and roles are assumed programmatically. To get an idea of this, let's create a role using the AWS console. I'm already logged in and will navigate to the IAM service. Now I want to create the role the EC2 instance is going to use for the employee directory application. Now we will click Roles in the left-hand side and select Create Role. We will then select the trusted entity this role is intended to be used for, and in our case, this will be EC2. Then we will click Next. Now we get to select the permissions assigned to this role. Again, permissions being what actions does this identity have the authority to take. We want this identity to be able to read and write to Amazon S3, so I will search for S3, and you can see there are multiple options here for pre-written policies that I can choose from. I also can write my own custom policy, which would also show up here if I created it ahead of time. I'm going to select S3 full access for the policy. In the real world, you would choose a more restrictive IAM policy for this, But for a proof of concept like this course is intended to provide, we will leave the permissions a bit looser for now. You would come back and change the permissions attached to this role to be more granular if this were ever to make it to a production type environment. Now we also need to add another permission here, and that's for DynamoDB. So I will exit out of the S3 filter and then type in DynamoDB and hit enter. And then we will select the Amazon DynamoDB full access permission. Then we will click next. Then we can give this role a name, which is employee web app role. Then we can scroll down and we can click create role. We can see that this role has now been created successfully, and if we click on the role and scroll down, we can then see that this role has 2 permissions attached. It's very common for roles to be used for access between AWS services. Just because 2 resources exist in the same AWS account, it doesn't mean that they can send any API calls to each other. If one AWS service needs to send an API call to another AWS service, it would most likely use role-based access, where the AWS service assumes a role, gains access to temporary credentials, and then sends the API call to the other AWS services, who then verifies the request. Another identity that can assume an IAM role to gain access to AWS is external identity providers. For example, let's say you have a business that employs 5,000 technical employees that all need access to AWS accounts. You already have an identity provider system in place that allows these employees to log into their laptops and gain access to various corporate resources. Should you also now go create 5,000 IAM users for these employees to access AWS? Well, that doesn't sound very efficient. You instead can leverage IAM roles to grant access to existing identities from your enterprise user directory. These are known as federated users. AWS assigns a role to a federated user when access is requested through an identity provider. We also have AWS services that can make this process easier, such as AWS IAM Identity Center. These are a couple of examples of role-based access in AWS, and this is just the introduction. Check out the class readings for more information, and don't worry if you don't quite grasp this concept yet, as we will continue using roles in our demos and examples throughout this course.
Hmm. I think this is what I want to do. Okay. You know, I should put on some stream music, shouldn't I? Ah, fuck it. I was studying, so. Okay, save that password. Nice, okay, cool. You know what, to be honest, I'm getting kind of sleepy. I think I'm going to lay down and take a nap. So it'll be a little bit short of a stream today, but everyone have a great rest of your day. I'll pick up this where I left off later on.